Hello, so we're gonna solve this network in terms of G of S over VO of S over VI of S. So in this network, we're given network in terms of or expressed in terms of time function. So we're gonna solve it in terms of the Laplace transform or Laplace or transfer function. So as we know that for the capacitance, H is equal to 1 over C of S, and for the reactance, F farad, and for the Henry is equal to S Rs. So, and for the resistance, R is equal only to the value of N or a given. So, let's see. We have here 2H. 1/2 F. So, if we express this into the transfer function, it will now be 1/2 S 1 over 1/2 is equal to 2 over S. So, for the Henry, for 2H, it will become 2S. And for the 3H, it will become 3S, and for the 1 ohm is equal only to 1. So we have now the new given expressed in transfer function. So if we redraw it, we will have one minus plus VI and of S for the transfer function. So, and then we have here VO of S, 3S, 2S, and 2 over S. So, now that we have the new network and the new given, so we can now manipulate for the solution. So, first we're gonna use the mesh analysis in order for us to solve for I2 and the rest. So, first, if we have assigned here this part I1 of S and I2 of S, or the first mesh or second mesh, and we have to manipulate it using the clockwise direction. So, we have here the first mesh, we have VI of S is equal to clockwise direction. We have the 2 is, and we have the given plus 1, and the first mesh I1 over S, and then minus for the I2 of S in the right side of the network. So the first mesh, then the second mesh is equal to 0. From here we have the negative I1 of S, and then plus we have the 3S plus 1 plus 2 over S times I2 of S. So we have now solved for the mesh 1 and mesh 2. So now take note that this part here, VO of S and 3S. So if we conclude that VO of S is equal to I2 of S times 3S. So later on, if there will be the value of V of S, we will input it as I2 of S times 3S. So let us manipulate. So if we want to solve for the value of I2 of S, we have to use the determinant method using the matrix. So we have here 2S plus 1, just use the method 2S plus 1, and here we have the VI of S And we have here negative 1 and 0. If we manipulate that, use the determinant. If you calculate that, you will be having the value of 1. And then for the denominator, we have the 2s plus 1, negative 1, negative 1, and then 3s plus 1 plus 2 over s. So, if we find its determinant, you will have the answer of 6s squared plus 5s plus 2 over s plus 4. So, we have now find the value of I2 over s. Take note that that's assigned here vi of s. So, if we want to manipulate it and let us manipulate it that the vi of s should be expressed in the denominator in terms of I2 of s over vi of s, because as we know that our formula is going to be g of s is equal to vo of s over vi of s. So we should manipulate vi of s regarding on what the formula of g of s is expressed. So I2, if we want to manipulate like this, so we have to cross multiply it by and multiply it by s. So therefore, if you multiply it by s, so that this vi of s will be bring down, I put it down here as denominator, so it will be s. So s times 6s is 6s cube plus 5s squared plus cancel 2 and now 4s. So now take note s over s for denominator and numerator. So now we have here s over 6s cubed plus 5s squared plus 2 plus 4s. Now we can solve now for the g of s is equal to vo of s is equal to vi of s. So take note that a while ago we know that v of s is equal to I2 of s of times 3s. So therefore, the value of s for the v of s is now 3 squared, because 3s times s is equal to s squared. Because as we know that I2 is in relationship with vo of s. Now the vi of s is 6s cubed plus 5s squared plus 2 plus 4s. So this will be the final result for this network. So thank you.